Okay, so let's share my screen. So, do you have any specific doubt in the week 7?
Not really. I mean, there was an issue with the grade assignment, but you already solved it. So that's
Okay, okay. Okay, so my screen is visible, right?
yes, yes, it's visible.
Okay, so week 7. So I'd suggest like solve all PA, and yeah, this will be sufficient for week 7. Like, so there will be one question maybe from this type of question will be there. So this is a practice assignment question, right? Consider the following hard k-means clustering problem with 4 points P11 and Q21 R43 and S5. Consider the number of cluster to be k equal to 2, so number of cluster is 2, and the initial center to be C1 equal to 0 0 and C2 equal to 2 4 4. Like, so asks like after how many iteration will be algorithm terminate and what will be the final center, right? So it's like in that k-means clustering problem, right? So what are the given? So let's write given data. So P equal to 1 1 and Q equal to 2 1, and R given is 4 3, right? 4 3, and S given 5 4, and number of cluster is given, number of cluster K is equal to 2, right? And initial centers is given, initial center is C1 0 0 and C2. There are two initial center is given, C1 is 0 0 and C2 is 4 4, right? So what asks after how many iteration will the algorithm terminate? So after how many iteration will the algorithm terminate, and what will be the final center, right? So you have to like find two things: first how many iteration and the final center, right? So let's see. So first iteration 1. So let's see distance of each point from, so let's find distance of each point from C1 and to C2 and C2, right? So P11 to C00. So what will be the distance? Anyone? This will be 1 minus 0 square plus
Root 2, right?
1. Huh? Yeah.
Root
Yes.
2.
Yeah. Root 2. Root 2. And P11 to C2 4 4, right? So it will be 1 minus 4 whole square, then plus 1 minus 4 square, it will be root 18, then Q 21 to C1 0 0, right? So it will be 2 minus 0 square plus 1 minus 0 1 minus 0 square, right? Right. So it will be root 5, right? Distance Q to 1 to C2 4 4. It will be 2 minus 4 square plus 1 minus 4 square. It will be root 13, right? Then distance that QR, lots of people are joining, I think.
No, Sachin is here.
Hi Sachin, nice to hear, nice to.
Hi, sir.
Hi, you are an OS student, right? Last time
What's up?
you are a OS student last time, right? Operating system you took last time.
I No, no, sir. It's not my last term.
Okay, okay.
No,
I
no.
think
So he's asking whether you had operating systems in the previous term or not.
Yeah, yes, sir. Yes, sir.
okay, yeah, that's it. Then R 43 to C1 0 0. So it will be 4 minus 0 square plus 3 minus 0 square. It will be 25, right? Then R 43 to C2 4 4. So it will be 4 minus 4 square plus 3 sorry, there will be no 3 minus 4 square, right? So it will be root 1. Then let's check S. So S, it will be yes, okay, Bimles, okay. I think I recorded. Maybe after that I'll upload to the YouTube and I'll share, Bimles.
Thank you.
Yeah, yeah. Nice to see you, Bimles, after long.
Sure. Same here.
Okay, okay. So then S 5 4, then to C 0 0, right? So it will be 5 minus 0 square plus 4 minus 0 square. It will be root 41, right? And S 5 4 to C2 4 4, right? So it will be 5 minus 4 square plus 4 minus 4 square. It will be root 1. So if you see the best on the distance, right? So we can see P 1 1, it's closer to C1. Q 2 1, closer to C1, right? So
The
let's
rest
add
are closer to C2.
yeah, let's add one page. It's not working. Okay, left. And that S43 closer to C2, and as this is R, right? And this is
R.
S. Yeah, this is 5 4 closer to C2, right? So this one will be from one cluster, and this will be one from one cluster, right? So cluster one will be P 1 1, another will be Q 2 1, another cluster will be R 4 3, and S 5 4, right? Then we have to find the calculate the new centroid, right? So how to calculate the new centroid? So let, if I can add the page, I'm not able to add the page. 1 minute. It's not working. Okay, I'll
Create a space and keep increasing.
yeah.
Create a text box and keep increasing.
Okay.
Or you can just you can add a new page. There's an
Yeah.
option
So
to create a new page, right? You can.
yeah. Okay. Now for new centered for C1. So if you, this is the suppose this is one cluster, same like this, and this is another cluster. So you have to create new centered, right? So how to create new centered? So it will be for C1, it will be 1 plus 2 divided by 2, and it will be 1 plus 1 plus 1 divided by 2, right? So it will be 1.5, and this will be 1. So new centered will be this, and another for C2, new centered will be 4 plus 5 divided by 2, another will be 3 plus 4 divided by 2. So this will be 4.5, 3.5, right? Okay, now let's do for iteration 2, right? So iteration 2, right? So iteration 2, what you have to do? So again you have to find all the things. So P 1 1 to C1 1.5 to 1. So it will be like if you calculate, so it will be 1 minus 1.5 square plus 1 minus 1 square, it will be 0.5. Then P then P 1 1 to C2 4.5 3.5. So it will be 1 minus 4.5 square plus 1 minus 3.5 square. So it will be 25. Now Q 2 1 to C1 1.5, then 1, right? So it will be 2 minus 1.5 whole square plus 1 minus 1 square. So it will be 0.5. Then Q 2 1 to C2 4.5 3.5. So it will be 2 minus 4.5 whole square plus 1 minus 3.5 whole square. So it will be root 18, right? Then R 4 comma 3 to C1 1.5 1. So it will be 4 1 1 1.5 square plus 3 minus 1 square. So it will be root 14 point something, right? Then R 4 3 to C2 4.5 3.5. So it will be like 4 minus 4.5
এটা vote
square
14
plus
হবে উপরে
14 point
I'm
something, 14.25 I think.
না না 10 something হবে
Okay, 4 minus 4.5, it will be 0.5. Sorry, it will be 1.5, right? Yeah, this is 4 minus 1.5. It's like 3 is
2.5 square, that is 6.25
huh.
and plus 4
okay. Wait,
10.25.
do we even need the exact numbers?
Yeah. So whatever, just I
I
think
was
whatever.
thinking if we just plot the values, we can. It might be easier to just determine the clusters, isn't it?
You can do anyway. So it will be, I think, yeah. So
No,
it
let
will,
us do it this way only because this will be
uh,
concrete.
so 2.5 will square. So 2.5 square will be
6.25
6.25 plus
4
plus oh yeah 10.25 something like that. Okay. Then 432, it will be 3 minus 3.5. So it will be like 0.5, right? Then S 5 4 to C1 1.5 1, right? So it will be 5 minus 1.5 whole square plus 4 minus 1 whole square. So it will be root under 25, right? Or something like that. Then S 5 4 to C2 4.5 3.5 root under 5 minus 4.5 square plus 4 minus 3.5 square. So it will be 0.5, right? Now based on the distance, so P 1 1, it's closer to C1, and P 2 1, it's closer to C1. Then P 4 3 closer to C2, S 5 4 closer to C2, right? So so like you can see that it's after the first iteration, like it's like after second iteration, like it does not change the like uh, that it's already in the C1 also, and also this P this is Q, right? This is Q, this is R, this is S. So PQ better to remove PQRS, right? So you can see that after the first assignment, it's do not change the first iteration, like that whatever the center is does not change, right? So you can see that after the two iteration, it's like same is, right? So final center will be 1.5 1, and another will be 4.5 3.5, right? So after two iteration, it's same, right? So correct option will be after two iteration, I think correct option will be C, right? Yeah, not C. That this option, D option will be that correct. 1.51 and 4.5 3.5 after two iterations. So this question everyone got it. So this type of question may come like one question will be there.
And don't give more than 2 iteration.
Yeah, it won't be there. Okay.
So one point here, I think in the grade assignment when I was doing it, um, I just plotted the points, and that was easier to do it that way,
Oh yeah,
because
you can.
instead of doing
Yeah,
all
you
the
can do.
calculations.
Yeah, you can do that way also. So whatever you
Yeah,
like.
if you give such points, then that will be easier.
So whatever you can do, like which method, like this is like simple only. If you plot the graph, you can also do that. So
No, but then Preeto, how will you know that how many iterations by plotting? You can find the cluster centers, but suppose question is
Yeah.
how many iterations, then that won't help.
No, I'm saying basically whatever we're doing here, I'll just I'll do
No,
the
no.
same thing on the plot.
Question here was like after how many iterations it will converge, and then given question was to find out the converged cluster centers. But suppose the question was like after how many iteration, then
Oh, okay,
this
okay, yeah,
calculation will be
yeah,
different.
yeah. Got it, got it. Yeah. In that sense, yes, correct.
yeah, 1 minute. Just office is closed, so I'm going outside. 1 minute.
So Gyani ma'am, good evening.
Good evening. Good evening. How's
I'm
it
scared
going?
for quiz. I'm scared for quiz 2.
Why?
So many things, and to be honest, haven't covered everything.
Okay. Uh, let's just follow the important portions and the way, like whatever the discussions was done during the last. Like, just follow that much. Don't need
PA
to.
PYQ will help get good marks.
Sorry?
PA, GA, and PYQ questions will help get good marks.
PAGA will only help for the topics that I had we had discussed yesterday. You know, like for one particular topic. Let me just check which one. Um, PAGA will help for the week 8 chapter.
Okay,
Okay.
and week 7 also, if you solve all the
Yeah,
PAG
week
and
7
PYQ,
also PA.
that will be sufficient. So solve all the practice assignment question and graded assignment question. So it will be like similar like that PAGA.
Okay, sorry. One point. Since you're talking about practice assignments, are
Yeah.
the practice assignments for week 7 and 8 verified and correct? Because earlier I remember Sugana ma'am said that the PAs are not being verified. So
For week 7 it's verified. You can,
okay.
yeah, for week
And
7.
week 8, Sugana ma'am, can you confirm that PA for week
Week
8 is
let me just check. Let me check. I'll confirm in a minute. Okay?
okay?
Suvendu, I'm still struggling how summation of RK, something like that was there in the lecture video, is coming one. I mean, there are so many notations in
Okay.
week 7, and I'm
Yeah.
struggling to understand all of them fully.
Yes. So don't worry. Like solve all the like this type of question. So this two type of question, it will be like we want to ask like summation of this kind of things. So this type of question and
So
one this
there
type
was
of
like soft version of K
yeah,
means version 1, version 2, version 3,
yeah,
version 4 was like exploding out of the screen itself. There were so many formula.
yeah. So we won't ask so many things. We'll ask simple this type of k-means.
Okay,
So
okay. Thank you.
yeah, don't worry. Yeah. Okay. So let's see this question. Okay. So find the maximum likely estimate with the parameter theta of a population having density function 2 by theta square into theta minus x for 0 less than x less than theta for sample unit size. So n equal to, give me right, n equal to 1, give me right. Okay, so what given? F x theta, so it given 2 by theta square theta minus x, right? So with a sample size, so n equal to 1, sample size given, right? Okay, so suppose x equal to theta, then what will be that? So it will be L of theta alpha, it will be, so f of alpha theta 2 by theta square theta minus alpha. So for the log likelihood function, so for the log likelihood function, it will be L of theta alpha, so it will be log L of theta alpha, so it will be log of 2 by theta square theta minus alpha, right? So it will be log 2
So
plus
sorry, in the first step you write log base 2 or something. What was that? Looks like a 2 after log.
it's log which person?
No, first step. I mean,
Log
L.
log L,
Yeah. Oh, okay.
log L.
L. Okay.
Yeah, log L. So it will be log 2 plus log theta minus alpha.
N equal to 1 means there is only one data point.
Yeah, there is one data point.
Okay.
So
And this function for theta is given.
yeah, x equal to alpha, we have, like assume, right?
No, it's asking for maximum likelihood estimate of parameter theta of a population with
Yes.
this density function.
So you have to calculate theta equal to 2a, theta equal to 4a, or something like that. Okay.
What is sample value?
Uh, it's given and function density
A
function
being
is.
the sample value.
মানে a কোথায় আছে?
So you can see x equal to, so what will be theta 2a or 4a or
X
something like.
equal to a is it's given x equal to a like that.
No, you can see that 0 less than x theta, right?
Yes.
So you have to find the what will be the theta value 2a or so alpha being a simple value, right? So alpha is given, so that's why you have to alpha, right? Then you have to find the what will be the theta 2a 4a or something like that.
Okay.
Yeah, so let's solve. So if you differentiate, so what will be? So if you differentiate dl, uh, sorry,
No, please scroll up a little. Scroll up
yeah,
a little more. So fx theta is given like 2 by theta square theta minus x.
yes,
Okay.
yeah,
For n equal to 1,
uh,
n is equal to 1 is given and x
yeah,
equal to theta. You are writing x equal to theta.
yes,
What is
correct.
x equal to theta means what?
So not x equal to, sorry, x equal to alpha, sorry, x equal
Yes,
to
so
alpha.
x equal to
Yes,
alpha. Okay.
yeah,
So
yeah. So
likelihood function is L theta alpha becomes this 2 by theta theta minus alpha. Okay. We are taking log of that, so it becomes like this.
yes, so dl
Now we have to
theta,
differentiate with respect to alpha.
yes,
What is
d
this
theta,
business of alpha? We could have done with x itself, no?
Wait, wait.
uh,
We are differentiating with respect to theta, right? Not alpha.
yeah, theta,
Sorry, theta. Yes.
theta. So it will be 1 by theta, 1 by theta minus alpha minus 2 theta equal to 0, right? So if you solve that, so it will be 1 by
Theta equals to
theta minus alpha equal to 2 by theta and theta equal to 2a. So 2 alpha, sorry. So it will be 2 alpha. Yes, any doubt this question? So like week 7 it will
What
be like
can be a twist? What can be a twist to this question?
twist, nothing, will simple, I will ask simple things, don't worry.
Okay.
Yeah, so week 7 again I am repeating, let's go for week 7. So solve all PA, GA and PYQ. This will be sufficient for you. So it will be simple only. Hello.
yeah.
Okay.
Can you
Yeah,
explain
for
the
me,
last?
Huh?
Sorry. Go ahead, ma'am. Ma'am, you were saying something?
I was just confirming that for week 7, PA is not been verified. You can look into the graded assignments for for week 8. But for week 8, I would suggest you to read figure 2.2 more as
Sugani,
compared to the.
Sugani,
Yeah,
I verified week 7, so it's all fine. Don't worry.
not for week
No,
7,
no.
week 8.
She's saying week
Oh,
8. She
oh,
said
okay.
week 7 by mistake right now,
Oh,
actually.
oh, okay, okay.
Yeah.
So week 7,
Yeah.
it's like all P and G are like it's verified. So only that two questions, I think I have posted in the group, right?
Yeah.
So
Yeah.
it's other things are
Which
all
two
okay.
questions?
That
Question
one
3
is,
and question 4.
yeah, question. You can
What is
check
the issue?
it.
You had given none of the above. So
But
can we try question 3, solving question 3 here if we have not done that already?
I think I pasted the solution.
Yeah.
Just check.
Sarah shared the worked out solution
Where?
already.
G space or where?
G space. G space.
Okay, I'll check that.
Also,
বিমলেশ
Naveen shared that. I mean, same thing.
বিমলেশ যদি অসুবিধা হয় তো আমাকে চ্যাটে মেসেজ
ঠিক
করবে।
আছে।
হ্যাঁ ঠিক
Okay,
আছে,
okay.
হ্যাঁ ঠিক আছে।
Sir, can you explain the last question for the grade assignment?
See, try first once. If you are unable to solve, then I'll give the solution.
Okay.
Don't worry. At least try something. That will be good,
Okay.
right?
Yeah. I mean, that was a theoretical question, but yeah, I'll look
Yeah,
into it once
yeah.
again.
If you are unable to solve, then ping me in the chat. I'll answer.
Okay, sir. Sure.
Yeah.
Theoretical questions I will be able to do because it has been discussed quite deep. That is why I was finding it difficult to understand few things.
Okay.
Yeah, but it has been covered in great detail.
Yes. Okay, then good night, everyone. If you have any question, then ping me in the chat or something like that. I'll answer.
Rito, any
Yeah, so
PYQ we have?
Huh?
To this, Rito?
I haven't started the PYQs. I'll do it now. Actually, I did not
Okay.
get time. I'll do it. So in case I face any issues, I'll just put it up on Discourse or something. I'll put it out on Discourse or in the chat space.
Okay. Sugyani ma'am,
Sachin,
any
Sachin,
Yeah.
any questions from your side? If you have solved the PYQ for this part,
Uh, I asked in the space like you guys saw that. मैं उसके बाद नहीं देखा मैंने.
okay,
One
okay, sure,
second.
sure.
Okay, so
Uh, it would be there. I will ping you soon.
yeah, so if like any doubt from week 7, especially in week 7, so just ping me in the sumendu@study.iitm.ac in ping me in the chat, I'll answer, or maybe like tag me in the discourse. Okay, so other than you can ask other week, you can ask to Sugyani ma'am.
Okay, for week 8, I would suggest you to just read that figure, the figure 2.2 from the book. The page number and everything I had discussed yesterday. Please read that book more than the graded assignments. That
ma'am,
figure will be
that figure 2.2, that page you told yesterday is open in front of me, but then what is that? Only one page you are saying is very important, or I mean, few pages
I'm saying
before and
that
after?
that particular page has the figure 2.2. That full page is figure 2.2, and I'm
Yes,
saying that you should understand how all the terms in that figure is getting computed. That's all.
l- like this motifs, scores, count, profile, consensus.
Exactly, all of that.
Okay.
That is like very important
So
from that
if you have
chapter.
if it's okay, can we discuss that figure 2.2 here if nothing else is being discussed?
Yeah, sure, sure, no problem.
Please, Prito, if that is okay.
Yeah, I don't have any more doubts from this because I haven't started myself. So
Okay,
yeah, you guys
then
can
if that
discuss that.
is figure 2.2, let us discuss, ma'am, please.
Okay, so let me just share that figure. Okay, is my screen visible?
Yes, ma'am.
Yes.
It's coming right now.
So,
Yes.
given this set of motifs, so we are having this t motifs, each of length n. So we compute the score. So how do we compute the score? Before computing score, I personally prefer computing count of motifs. So what is count of motifs? It is basically in each of these for each of these A, C, G, T, we have four different nucleotides. For each of the four nucleotides at this particular position, what is the number of number of motifs containing that particular nucleotide? So, like for example, in this first position, if we search for A, how many motifs? So basically, what this number means is how many motifs are there at the first position containing the value A. So here, as we can see, A is in this third motif and A is in the fifth motif. So there are two motifs containing A at the first position. So we have two here. Okay. Similarly, for C, there is one motif containing C at the first motif, so first position. So C has the value 1 in count of motifs and T has the value 7. So basically, what in count of motifs, what you will do is you will just count how many times this nucleotide occurs at in the in the ith row of that of
Ma'am, this
set of
small a, small c has anything to do with here?
yes. So what this is actually meaning is T is the dominant nucleotide in this position. So that is why it has been represented as capital. This is just a notational issue. Okay, so here T has been, the capital T means that T is occurring in most of the nucleotides, but it is not necessary that in the examination or in any other, like whenever you are doing, in reality, you will be having a capital T at some positions and a small a at some positions. All of these will either be capital or all of these will either be small. So what this means that in count of motifs, what you do is you just count how many times T occurs, how many times A occurs, how many times C occurs, how many times G occurs, and this ith position. Okay. So now here, as we can see that T is having the most number of occurrences in the first position. So that is why T has been written as capital. That is the only reason why this is capital and why this is small. Okay, so what you do is for each of these positions, so there are like 1, 2, 3, 4, 5, 6. So that this is an n length motif. So in for each of the n positions, we have to calculate how many times A, C, G, T are occurring. That's all.
So basis the motif matrix, we have to convert that into count motif matrix.
Exactly.
That is okay.
Yes.
So, but,
Yes.
but before that, what is the score?
Coming to
3
that,
plus.
I'm coming to that. I'm coming to that. The reason I said to use count of motives will be clear. First of all, why you should go for count of motives. So once
No, what I
count of
understand is that from count of motives, whatever is the highest in particular column, we remove that and add all other things, and that becomes
exactly,
a score.
exactly, score of that particular position, score of that
Yes,
particular
we
position.
remove the highest, and but suppose there is a tie in that case. I mean, there are two values with the same score in the same column.
Then you should go with, see, suppose there is a
So
tie,
instead of
then
2107, suppose it was like uh, uh,
let's say there are 11 motifs and you are having 5, 5 and 1. Okay. So in that case, you can either go with the one of the 5 and the other of the 5. See, one of the nucleotides will be the dominant nucleotide. The other nucleotide is not the dominant, it's erroneous. Okay. But it has occurred multiple times. So doesn't matter, but it is erroneous. Okay. So we don't know whether it will be, let's say A and C are having 5 and 5 and G is having 1. So A and C, we don't know whether A will be the correct one or C will be the correct one. But for the score, when we are computing the score, what will happen? There should be 5 of these nucleotides are wrong. Because let's suppose it should be A, then all the 5 occurrences of C is wrong. Right? So it will be, the score will be 5 plus 1 for that particular position. Am I making sense?
no, I didn't get that. See, A, C, G, T, there are four things. Right
Yes.
now it is 2107. Okay. So
Okay.
instead of 2107, let me let the highest is 7. Instead of, if we can make it like T is
Yeah. That, let me give me a
T is
minute.
4, A is 4,
Okay.
and C
It has to
is
add to 10. Whatever you do, it has to add
4,
to
4.
10.
Yeah, T is 4, A is 4, and C is 2. Something like that.
Yeah, so we cannot
A
determine what is
and
dominant, right?
4 is whatever showing in this clear. Let's say that there is another.
C is
Can you
2,
see
G is
the
0.
Can you see the markups?
Yes, yes,
Yes,
yes. It's
yes.
visible. Yeah.
Okay, wait. I'm coming.
You have added those numbers to the left, to the right
Yeah,
side. It's
let's
visible.
say there is the 11th. Each of these motifs are of length 11. There is one more column here, and in that column, this is the score. Okay, A is having 4, T is 4, C is 2. Okay, hello.
Yeah, you're audible. Yes.
Yeah. So in the last column, we are having, there is another imaginary column here in which we are having, this is the count of the motifs. So now see what happens here is, we don't know which, see, either A is the dominant nucleotide, or T is the dominant nucleotide. You agree with that, right? We
Yes,
don't
yes.
know which one is the dominant nucleotide, but A is either the dominant nucleotide or T should be the dominant nucleotide. So if we will be having the correct, so this is basically we are reading the nucleotides, right? So when we, if the actual one is, suppose it should have been A, but we are reading T as erroneously. Okay, for some reason the machine has read T erroneously. So it should be A. I am telling you this extra information. Then what should be the score for this particular
It should be
column?
6. 6.
It will be
4
6,
plus 2.
right?
No,
Right.
no, what is the basis?
What
So
I'm saying is,
they have determined that adenine is the actual one. So the other ones
what
are
I'm
erroneous.
yeah, all the other ones are erroneous. I'm telling that beforehand to you. I'm telling that I know that in the 11th column, A should be the correct motive. A is the correct motive. I'm giving you a reference and I'm telling you that A should be the correct motive at the 11th position.
Then we add only C and T, you are saying. C, T,
Exactly.
and
Then
G.
you should have, yeah, exactly. C, T, and G. So which is basically 6,
Okay,
right?
so if
Now,
you are saying in such a scenario, then this extra information has to be given. Otherwise, there is no point of calculating score.
no. I'm coming to that. I'm coming to that. Suppose I'm giving you the information that T is the dominant motive, then what is the score? The score is still 6.
Acha, anything you can out of 4, any one you can say. Then we can add up balance 3.
Yeah, out of these two, if you fix one of them as the reference as the correct one, then all the other three will add up to the same value. That is what I want to point out. So the score will be 6.
No, you can always say that C is correct. Then score can be 8.
Yeah. If I'm saying that C is correct, then score is 8. But
Can you also say
when
that
we're
both A and C
calculating
are correct? No,
no. Both A and C cannot be correct. What I'm
only
saying
one has
is
to be. Yes.
one has to be correct, and the other one, when you add it, it is the score. But because we do not know the reference genome, what we are taking as the score is we are just adding up the remaining values. We are just
Correct.
removing the dominant one and we are adding up the other value, other numbers. Okay. So here, because we don't know the dominant one, the question is arising which of these should be considered as the dominant one. What I am putting forward is whether you consider A as the dominant or T as the dominant, it doesn't matter because the score doesn't change.
Correct.
That is what
Yeah,
I
that is
want to
okay.
point.
Correct. Yeah, but as a, I mean, from theory viewpoint, this is what it is. And
Exactly.
also when motif is given, so as a standard, this correct correct one will be given, will be capitalized, and wrong ones will be in small case.
Yeah, this is from the book notational point of view. Okay,
Yes.
this is not what happens in practical life. Okay, that is what I
And in the
want.
exam, and in the exam, this notation might not be followed. Correct.
Might not be followed. Yes,
Then what can be the twist to that?
the twist will be you have to count.
We just count and get the numbers. That's all. Doesn't make a difference that way.
No, no. In the exam, this only motifs matrix will be given. Correct. What I was saying, I mean,
See,
from
what
motifs
I
matrix.
want to point out here is it is not necessarily that the motive matrix will be given. It may be possible that you will be given the count matrix and everything else is asked to compute. You may be given the profile to score, may be asked. Score to profile will not be asked, but profile to score may be asked. Count to score may be asked. Score
Acha,
to count may be,
sorry.
profile to
Yeah,
consensus may be given. Maybe this figure will be given and you will be asked to find the consensus.
understood.
Okay.
So motive, score, and count is clear. Can we please dwell upon profile, motives, and consensus?
Okay. Yeah. So consensus, what you have to do is see for the just okay. I'll come to that. So for consensus, it's basically from this count of motives, you just pick the one nucleotide for every position. You find the nucleotide which is dominant. Okay, so which has the highest number, which has the maximum value. Okay, so for example, in this particular for the first position, out of 2, 1, 0, and 7, T has the max. T is present in most of the uh, motifs, right? So T is have in 7 of the motifs. T is present, which is the
One
maximum. So
doubt here.
that is the
One doubt here.
coming
One
to
doubt
that.
here.
I know your doubt. I'm coming to that. Okay.
Yeah.
So T is having 7. So that's why we will put T as the nucleotide at this particular position. Similarly, we will repeat that for all of these different nucleotides, for all of these different N positions. Okay. We find the nucleotide which has the maximum value, and we write that nucleotide at that particular position. The final string is the consensus, like T, C, G, 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 A, T, 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 C, C. That is the consensus. Okay. So now coming to the question for this particular column where we are having two different nucleotides with the same value, we will not be able to determine the consensus. There will be two consensus in this scenario. One of the consensus will have A at the last position, and the other consensus will have T at the last position. There is no but one fixed, one unique consensus is not there. Okay.
Yeah. So basically, consensus has to be like for the maximum number of count. It can't be like suppose in the first column 7 is can be incorrect and consensus can be for A. That won't be possible.
Sorry, can you please repeat?
So suppose can it be so that this count is given and
Yeah.
then it is also given that A is the correct one, correct motive instead of T.
If A is the correct motive, then in the reference motive, you are said that A is the correct motive. Then see, basically consensus of motives is means that what is the reference? The idea behind consensus is forming the reference motive. We want to generate what is the actual motive, what nucleotide is at what position. So if you already know that A is the correct motif at the first position, there is no there is no question of like generating the consensus because it doesn't have make any meaning. So consensus means we don't know what is the reference genome. We don't know what is the motive reference motive. Okay, so we don't know what should be at this particular position. So what we are doing is we are just taking all of these samples, we are reading these nucleotides at every position, and we are finding what is the maximum, what nucleotide is present at the maximum number of samples. That's all we are doing so that we can get an idea on what nucleotide should be present in that particular position. Okay, that is the idea behind consensus. So if we are already knowing the underlying reference genome, then we already know that there should be A at this first position, then there is no point of finding the consensus and doing all of this.
Okay,
Okay,
good.
so when I said that the reference genome has A at this position, then the score will be 6, and if it has T at this position, the score will also be 6. That was only to explain the fact that no matter whichever is the dominant nucleotide, the score doesn't change. So that is why the score is fixed, but the consensus is not fixed in this scenario. Does that
Okay.
make sense?
Yes. And how about profile?
Okay, so now profile is very easy. Once you know count of motifs, what you do is for profile basically means that what is the probability of occurrence of that particular nucleotide at that particular position. So for this first position, what is the
Divided by N
probability?
for each column.
Exactly. So divide by n for each of these values. More to say like divide by n for each of these values. So for A there are 10 motifs. So the count was 2. So I just divide by 10 and I'm getting 0.2. For C it's 1. So we divide by 10 and we get 0.1. For G it's 0 by 10 0. And for T 7 motifs we're having the position T. So the probability is 7 by 10, and hence profile of motifs will have 0.7 for the nucleotide T at the position 1. That's all.
And what is this? I mean,
Right?
graph
Now
given?
this figure is basically what it is doing is it's representing all of these nucleotides, the probability of these nucleotides figure like thing. Okay, so this is basically
The length of the letters it's corresponding to the probability of that, as is shown in that
exactly,
axis.
yes, the
No,
length
it doesn't,
represents
because
the
it is
probability.
touching two. It can't be, I mean, crossing one.
This is actually the number of bits required to store that nucleotide. So like here we are having this 10 what this is 10 motifs, no? So we need to store G 10 times, right? So at this particular column, so what is the number of bits required to represent G? So I do understand that this is the bits, but how to generate this is basically done from the profile of the matrix. So whatever is the probability, that will require the highest number of bits, right? Sorry, that will require that percentage of the bits. Okay, so suppose to represent one column of this motifs, we require 2 bits. Then here G is having like probability 1, so G will occupy the entire like there will be G at all the values in the all the cells in that particular column in the matrix, right? So that means the probability. So G is represented as like bigger one. The height of G will occupy the entire from 0 to 2. Okay, in
Wait,
this
why are we
first
thinking
column,
about it in terms of bits? I thought it was probability. I mean, where
it
does bit
is.
come into the picture?
This is basically a representation for the storage. Wait. This is basically, sorry, here the the height of the letters depicts the information content of the position. Okay, so bits is coming here because we are trying to represent like what is the inform. This is basically the information contained in that particular position. Okay, so the information contained in that position is, see, like here we are having this 7 T's, which means that T is occupying like 7 bits or something. Seven of these cells, the information contained in 7 of these cells is T. So that information we are trying to represent. Here, if you read this clearly, the motif logo is a common way to visualize the conservation of various positions within a motif. Okay, so it is basically the height of the letters is depicting the information content. So here G is contained in all the motifs that is being shown here. That is all we are saying, that G, the height of G is like it's the full height. So that means that G is contained in all of these cells. So now here P is occupying this many number of bits and A is occupying this many number of bits. That is what they are trying to represent here.
So, from exam point of view, which all kind of questions could be asked from this figure 2?
From the motifs count, calculate score, calculate count of motifs, from motifs to count, from motifs to profile, from motifs to consensus, from profile to
So,
consensus,
will it
count
be
to
like
consensus.
finding the entire matrix or for a particular column?
Depends. Sometimes, like sometimes you may be asked like what should be the values in these columns. It can be asked. Obviously, you will not be asked to write the entire matrix because this is MCQ and it is. But you may be asked to like what is the score at this position? What is the score at this position? Like what value should go in this particular position? What is the consensus at this position? That's
So
that
anything
kind
like complete the matrix can also be asked.
yeah, kind of like complete this work. Not complete the matrix means all the 4 cross 10 values needs to be filled. All the 40 values will be asked, but yeah, some of the missing values may be asked. Some of the values at this particular positions may be asked. You know, kind of that. Okay. Apart from this, from the profile of motifs, there will be, suppose you are given one particular, this one is a little bit important. So let me just discuss that part. Suppose you are given a median string, you are given this string, okay, you are given this pattern and you are asked, not this one. Let me see. Probability that the pattern is the consensus string or something of that sort. Mm, Okay, I don't know why I'm not able to find this, but it may be asked here, what is the probability that this particular string is the consensus? Okay, hello?
How to find that, ma'am?
Yeah, see, so first of all, when this kind of question will be asked, that means that that particular string is having length n as equivalent to the other motifs. Okay, and the second it will be written something like this: probability that something like A T uh, G G G G C A T T given the profile of motifs. Okay, so basically this means that what is the probability that this particular string is the consensus. Okay, given the profile of motifs, find the probability that this is the consensus string. So this means, so what we have to do is, we are assuming that each of these positions are independent. So what we need to do is, we just need to find the probability of this nucleotide at that particular position and just multiply it. Okay, so A is at the first position, the probability that A is occurring is 0.2, right? So this value will be equal to zero point 0.2 times. Then the probability that there is
Ma'am,
the
if any of the
here
probability is 0, then it will become 0.
exactly.
Acha.
Yes, if any of the probability is 0, then it will become 0. But here I made sure there is no zeros when I was writing this string. Okay.
So it will be a very minuscule probability in that sense. Or
Yeah.
you can ask like, write in terms of 10 raised to power minus something, like in quiz 1.
Sorry.
So in quiz 1, there was something like, what will be the value of x if it is counted in terms of x times 10 raised to power
Yeah,
minus
yeah,
8?
yeah, yeah. Yeah, yeah, yeah. Something like that might be given. Okay, don't worry about that. Okay. Any other questions from this?
These things I will commit a mistake, because on screen counting how many letters itself can be
I would
erroneous.
suggest to have a paper and pen and paper with you when you are solving this quiz 2 or something.
Yes, yes, that we always have.
Yeah, so better to just write it down. Write down the matrix from the screen first of all, and then you do the
Write down the
computation.
matrix. Okay, okay, understood.
When it's given to you, just write down the matrix and then you do the computation on the paper.
In
Otherwise,
in
from the
artificial intelligence paper, I don't know whether that is feasible here, but they used to give us printed graph papers based on the questions which might be asked. We used to
okay,
get printed graph papers.
I am not aware of that.
No, but why do we need it here, the English?
बोलो तो टुके नहीं थे.
Oh, for the matrix.
Yes, yes. Anyway, that, I mean,
I
that
can
can be done.
assure you one thing, we will not be giving long motifs, right? So this n length motifs, no, that is not going to be something like 30, 40. They'll be smaller sizes, okay? It
Okay,
will
okay.
not be
Thank you.
too long.
Thank you.
So the matrices will be small, and I would actually suggest you to just write it down on the paper and
Yeah,
then do
that I
the.
will do. Without that, I won't be able to solve. I mean, I doubt every time I count.
Yeah, that happens.
That happens with me also. Don't
Yeah.
worry too
So
much about this quiz, eh?
this is from, I mean, one important thing you stressed upon yesterday also from week 8. Uh, other than figure 2.2, there was something like median string algorithm. Can we discuss that also?
Median string algorithm, we can discuss, but it's not that important. Don't worry about it.
Okay, okay. No, you were saying no something like that.
Think about the complexities of these, rather than the median string algorithm, think about the time complexity of calculating, time complexity and space complexity of calculating these, all of these values that we
Calculating what?
the these quantities, you know, this score, count, profile, consensus, this
Can we discuss
this
that right now?
probability.
Basis this example, let us
No,
discuss that.
no, no,
Hello?
no. We can't discuss that. Uh, think about the running time complexity and the space complexity of counting these quantities, the
Of
score and
count
count.
motives.
Of all of these, of count motives, profile motives, all of these. Think what, suppose you are writing a code for this, okay? Suppose you write an algorithm for this to
Mm-hmm.
compute score of motives, a count of motives. What will be the running time and the space required? What will be the time complexity of your program? What will be the space
Okay,
complexity
okay.
of these?
So for this figure 2.2 or whatever algorithms are there, there are pseudocodes. So what will be the complexity for those pseudocodes you're saying?
Yeah, yeah.
Okay.
What will be the time complexity of computing these values? What will be the space complexity of storing these numbers? Okay, so all of that you should think about that. That will be more helpful than the median string algorithm.
Okay.
For week 5, just read the pseudocodes of the two algorithms, additive phylogeny and neighbor joining. Hello, hello,
Yes, ma'am.
hello. Yeah.
Yes, ma'am. Ma'am, can you explain the difference between additive phylogeny and the NR algorithm?
Neighbor joining.
Yes, ma'am.
Okay, they are like completely different algorithm. Neighbor joining is more. Okay, I'll just stop sharing this. Mm, wait. Neighbor joining is more like uh, you find the one with the maximum value. Wait. Say neighbor joining algorithm. What we are doing is we are just finding the maximum values. Sorry, not the maximum values. That was UPGMA. So I got confused. We compute this D star and then we find the one with the minimum value and we just remove it. Okay, so this is more like a clustering form of algorithm. Okay, we find this I and J are having this minimum value 68 in this D star matrix. So we remove IJ from the column and we create a cherry kind of thing. What like the terminology used in the book, it's called cherry. So we form this new node which is connected to both I and J, and they have named it as M. Okay, so we form this node called IJ, which is connected to M, and then we calculate the distance of M to the other remaining nodes. That's all. Then we compute again D star, and we find whatever is the minimum. So here KL value, the sorry, M to K is 34 and M to L is 34 minus 34 and K to L is minus 34. So minus 34 is the minimum. So here we can take M to K or we can take K to L. In this particular example, in this book, they have taken KL as the minimum value. So they made a they made a new node and they joined this K and L to that. Okay, and then they named that node as A and then removed KL from this matrix. So the rows containing K and L and the columns containing K and L, both of them have been removed. Okay, and they added a new row and a new column, which is called a A, and they calculated the distance between M and A. So now between there are only two nodes, so we just do this connection. This is an easy algorithm, right? All you need to know is the formula to compute this D star matrix. So that formula is given here. D from K to M is equal to 1 by 2 times D Ki plus, sorry, not this one. This one. D star ij equals to n minus 2 times dij minus the total distance minus this total distance. Total distance is basically the row sum or the column sum. You can take the row sum, you can take the column sum, either. So here when we are computing D star, you just need to take this thing you should be careful. When you are computing D star here your n is equal to 4, right? But now you have removed ij and you have added this new node called m. So we are having three nodes only. So here when you are taking computing d star on this particular matrix, your n will be equal to 3. Okay, so that's all. Similarly, you just keep on doing. You know the formula to how to compute D star, and once you compute D star, you just remove these. Find the once you compute D star, you find the one with the minimum value, remove it, and then you remove those two nodes, add those two nodes as a cherry thing, and add a new node connected to these two nodes. Okay, and the new node you just name it something like here it has been named as A, and you put that A and you calculate the distance between M and A. So how do we calculate the distance between M and A? It is basically what is the distance between. So A is formed by connecting K and L. So it is basically you take the average. So M to K is 10, M to L is 11, right? So 10 plus 11. How did it become 4? Um, Oh, sorry, that is minus also. Okay. So this is basically computed as 10 plus 11 minus 13. So M to A is basically the distance from M to K and M to L minus the distance between K and L. Half of that. Okay. So this will be 21 minus 13 by 2. You will get 4. Okay. That's all. So this is the neighbor joining algorithm. Is this clear or you have any doubts?
What kind of questions can be asked from this, ma'am? Like, we have to solve the entire matrix, or
No, I would say like questions would be something like given this pseudocode, what should go in this fill in the blanks? That can be that kind of question. It can be from either additive phylogeny or from the neighbor joining algorithm, something like that sort of. You can have questions like what will be the um, you can be asked to fill in the blanks for this sorry, what is that, for the algorithms, or you can be asked for the additive file for the neighbor joining algorithm. Suppose first of all you are taking you can be given a matrix, this D matrix, and you can be asked compute what will be the tree. Okay, so what will be the tree, and for that you will be given, like suppose in case there will be ties, you will be given that we are choosing K and L in this particular condition where we are having ties between these two nodes. We will be choosing K and L as over M and K or M and L. Okay, so in this, for this second iteration, we will be choosing K and L to resolve the ties. We will be given that, you will be given that, so the tree will be fixed. Okay, so you can be asked to choose what is the tree. In case of additive phylogeny algorithm, you can be asked to calculate this limb lengths or this D star, right? That's the additive phylogeny algorithm. In additive phylogeny, you can be asked to calculate this limb length of J or limb length of this, or in this case, like tree of D trim, sorry, no, D trimmed or D bald. What will be in this? We are computing the D bald. Like suppose I'll just give you a sample question. It's not there in the exam. Given this D, we are choosing I as the first node. We are choosing I as the first node. So we are computing limb length of I. Then we are generating the debald of the matrix, and we can ask you questions like what will be the values at these positions. Okay, so something of that sort. Like computing, you should understand how you will compute this limb length, how to compute this debald, how to compute the detrimmed. Okay, and then how this tree is getting constructed. Like maybe just run the algorithm on this particular example and see how it is constructing the tree. Okay, and just read the pseudocode. That's all. So
Okay.
all this how these formulas are being computed both for additive phylogeny and for neighbor joining algorithm. How these formulas are getting computed? What are the formulas to compute these values, and how to compute these values? Okay, and then once these are computed, how to construct the tree. That's all. And then just look at the pseudocode, like try to understand what is happening in the pseudocode, so that will help a little bit.
Okay. Thank you, ma'am.
Any other doubts, questions? Any other doubts or questions? Suvendu, you there?
Yes. Okay, so all the best for quiz 2. So do well in the quiz 2.
Thank you, sir.
All the
Uh,
best.
Thank you,
Sir,
sir.
Thank you. Thank
please
you.
do share the recording. I mean, at least the link of that, if you don't
Yeah,
have
I'll
or
upload in
something.
the YouTube maybe in the night. Just ping me in the chat. I'll upload in the YouTube.
Yeah, please share by tonight itself. Link in the G space, please.
Yeah, I'll share. Okay.
Thank you.
Okay.
Good night.
Thank you, sir.
Yeah.
Good night.
So good night, everyone.